Welcome back friends. Welcome back to another video session from this channel. So in this video session we will be studying regarding the specific mechanism, the specific process which is involved in organizing the alternative splicing mechanism in case of higher eukaryotes. Is it clear? So what is alternative splicing mechanism? What are the various strategies which are in association in the organization of alternative splicing mechanism, and what are the various factors which govern the alternative splicing mechanism in case of higher eukaryotes? Is it clear? So for your better understanding, let me write it on the board. So what it is? Alternative splicing mechanism, right? Alternative splicing mechanism. So here the alternative splicing mechanism most commonly observed in case of higher eukaryotes. Is it clear? It is observed in case of higher eukaryotes. Higher eukaryotes, right? So for the very first time, the alternative splicing mechanism, it was observed in case of a particular eukaryotic gene which is responsible for organizing the adenovirus replication mechanism. So let me write it here. Adenovirus replication mechanism gene. Then after, in many of the eukaryotic genes, the alternative splicing mechanism, it is successfully observed. And these genes include SLO gene in case of rats. And in addition, troponin gene, right? And even it is observed in case of the DSCM gene in case of Drosophila. Is it clear? So here now my question is, what is the meaning of alternative splicing mechanism, or what is the uniqueness of alternative splicing mechanism? So here, prior to the explanation of alternative splicing mechanism in detail, at first let us recall the basic splicing mechanism which is most commonly observed in case of eukaryotes. So here if we consider one particular eukaryotic gene, when it undergoes expression during the transcription mechanism, it synthesizes a single stranded mRNA, or here it synthesizes a primary transcript. Is it clear? So here the primary transcript, it consists of both the coding sequences and as well as the non-coding sequences. So here the non-coding sequences are the introns which are a part of the primary transcript. They undergo splicing. So once when the non-coding sequence or the intron, when it undergoes splicing, under such condition, from the primary transcript, a mature RNA or intron-free RNA, it is successfully synthesized. So here the intron-free RNA or mature RNA, when it participates in the translation mechanism, under such condition, the particular mRNA, it is capable to induce the synthesis of the polypeptide chain during the translation mechanism. So here this is the basic concept of the RNA splicing mechanism which is most commonly observed in case of eukaryotes. So here, in addition to the normal splicing mechanism in case of higher eukaryotes, there is an availability of one more other alternative strategy through which the splicing mechanism, it is successfully organized. And here the alternative strategy, it is nothing but what? Alternative splicing mechanism. Is it clear? So here, what is the uniqueness of alternative splicing mechanism? So for your better understanding, let me present it on the board. So here, let us consider one eukaryotic gene. So here the eukaryotic gene, when it undergoes expression during the transcription mechanism, is it clear? So here it synthesizes in primary transcript. So here the primary transcript, it is an association of both the coding and as well as the non-coding sequences, right? Primary transcript. So here it is nothing but the axon, and here it is nothing but the intron, and again it is axon, and again here it is nothing but the intron. So here in case of the alternative splicing mechanism, what exactly happens here is alternative splicing mechanism, right? So here let us consider one particular axon which is nothing but axon 2. Is it clear? So here once when the particular axon 2 when it undergoes skipping during the alternative splicing mechanism, under such condition from one primary transcript multiple RNA variants they are successfully synthesized, and these alternative variants which are successfully synthesized during the alternative splicing mechanism, when they participate in the translation mechanism under such condition they are capable to induce the synthesis of the polypeptide chain. Is it clear? So here it is the uniqueness, or here it is the beauty of alternative splicing mechanism. That means from one particular eukaryotic gene, multiple proteins are successfully synthesized. Is it clear? So let me print it here. So here it is nothing but one of the alternative mRNA, right? So here it consists of axon 1, axon 3, and here it is nothing but the axon 4. So here axon 2 it is not successfully expressed, and here in the other alternative variant so here it consists of axon 1, axon 2 and axon 3. So it is one of the alternative mRNA and it is the other alternative variant. Is it clear? So from one primary transcript, two alternative variants they are successfully synthesized by the means of alternative splicing mechanism, and these alternative variants when they participate in the translation mechanism under such condition they are capable to induce the synthesis of the polypeptide chain. So that is the uniqueness, or that is the beauty of alternative splicing mechanism. Is it clear? So here the alternative splicing mechanism in case of higher eukaryotes, it is successfully organized by the means of various strategies. So what are the various strategies through which the alternative splicing mechanism in case of higher eukaryotes it is successfully organized? And these strategies include exon skipping. Is it clear? Exon skipping, mutually exclusive exons, and the other one is alternative donor site, alternative acceptor site, and the last strategy it is nothing but what? Intron retention. So for your better understanding, let me print it on the board. So let me arrange the things first. So here the various strategies of alternative splicing mechanism include exon skipping, so let me write it here. What it is? Exon skipping, and the other strategy is nothing but what? Mutually exclusive exons, and the other strategy is nothing but what? Alternative donor site, and the other strategy is alternative acceptor site. Is it clear? And the last strategy is nothing but what? Intron retention. So at first we will be studying regarding exon skipping. So what is exon skipping? So here let us consider one eukaryotic gene. So as I have already mentioned you, when an eukaryotic gene, when it undergoes expression during the transcription mechanism, is it clear? So here it synthesizes a primary transcript, right? So here it is nothing but the primary transcript. Primary transcript. So here the primary transcript, it consists of both the coding and as well as the non-coding sequences. So here, in case of exon skipping, what exactly happens here is, one of the particular exon, it undergoes skipping. So here let us consider the exon 2. Is it clear? So here once when the exon 2, when it undergoes skipping from the primary transcript, under such condition, from one single primary transcript, two alternative variants, they are successfully expressed, and these include, so here it is one of the alternative variant and here it is the other alternative variant. So here there is an availability of exon 1, exon 3 and exon 4. Is it clear? So here the exon 2, it is not at all successfully expressed, and here in case of the other alternative variant, here there is an availability of exon 1, exon 2 and exon 3. These are the alternative variants, right? Alternative variants which are successfully synthesized by the means of exon skipping. So here this is regarding exon skipping. And the other alternative strategy through which the alternative splicing mechanism which is successfully organized in case of higher eukaryotes include mutually exclusive exons. Is it clear? So what is the meaning of mutually exclusive exons? As the name itself suggests, in case of mutually exclusive exons, instead of undergoing one particular exon skipping, in case of mutually exclusive exons, both the exons, they undergo skipping simultaneously. Is it clear? So the reason why here it is termed as mutually exclusive exons. Is it clear? So let me print it here. So here let us consider two exons, exon 2 and exon 3. Mutual exon skipping. So here in one of the alternative variant, exon 2 is expressed, and in the other alternative variant, exon 3 is expressed. Is it clear? Both the exons, they undergo skipping from the primary transcript simultaneously, and in neither of the two alternative variants, both the exons, they get successfully expressed. In one of the alternative variant, one particular exon is not at all expressed, and in the other alternative variant, the other exon, it is not at all expressed. Is it clear? So here this is nothing but what? Mutually exclusive exon skipping. And the other alternative strategy through which the alternative splicing mechanism which is successfully organized in case of higher eukaryotes include alternative donor site. Is it clear? So what is the meaning of alternative donor site? So for your better understanding, let me print it on the board. Here, as we all know, 5' splice site, or it is otherwise known as donor site. So here in case of the alternative donor site, what exactly happens here is, instead of using this particular consonant sequence for organizing the splicing mechanism, the other consonant sequence which is a part of the primary transcript, it is successfully used, so that the 3' boundary of the upstream exon, it remains successfully varied. So here it is nothing but the 5' end, and here it is nothing but the 3' end. So here instead of using this particular consonant sequence, if any of the other consonant sequence of the primary transcript, if it is successfully used, under such condition, the 3' boundary of the upstream exon, it remains successfully varied. So here it is nothing but what? Alternative donor site. Is it clear? And the other strategy through which the alternative splicing mechanism, which is successfully organized in case of higher eukaryotes, include alternative acceptor site. Is it clear? So let me print it on the board. So what it is? Alternative acceptor site. So here, as the name itself suggests, likewise the donor site, the primary transcript, it also possesses or it also consists of 3' splice site, which is otherwise known as acceptor site. Is it clear? So here, instead of using this particular consonant sequence, if any of the other consonant sequence of the primary transcript, if it is successfully used, under such condition, the 5' boundary, is it clear? The 5' boundary of the downstream exon, it remains successfully varied. So here it is nothing but what? Alternative acceptor site. Is it clear? And the other alternative strategy through which the alternative splicing mechanism, which is successfully organized in case of higher eukaryotes, include intron retention. Is it clear? So what is the meaning of intron retention? So here the other strategy of alternative splicing mechanism include intron retention. So what is the meaning of intron retention? So once when a eukaryotic gene, when it undergoes expression, is it clear? So during the transcription mechanism, it synthesizes a primary transcript, right? Primary transcript. So here the primary transcript, it consists of both the coding and as well as the non-coding sequences. Primary transcript. So here, during the splicing mechanism, what exactly happens here is the non-coding sequences are the introns. So here it is nothing but what? Exon, and here it is nothing but the intron, and again it is exon, and again here it is nothing but what? Intron. So here during the splicing mechanism, the introns, or which are nothing but the non-coding sequences which do not have any biological role, they undergo splicing. But here in case of intron retention, what exactly happens here is instead of undergoing splicing, the particular intron, it remains in association with the particular exon. Is it clear? So here let us we consider exon 1. And here there is an availability of intron, and here there is an availability of exon 2. Exon 1, and here it is nothing but exon 2, and here it is nothing but the intron. So here instead of undergoing splicing, the particular intron, it remains in association with the particular concerned exon here. So here it is nothing but what? Intron retention. So here all these are the various strategies of alternative splicing mechanism which is successfully organized in case of higher eukaryotes. So here in order to organize the alternative splicing mechanism in case of higher eukaryotes, there is a requirement of certain factors, and these factors, they are nothing but what? Exon splicing enhancers. Is it clear? So let me write it here. What are those? Exon splicing enhancers. Is it clear? Exon splicing enhancers, and the other one is exon splicing silencers. Exon splicing silencers. So here the exon splicing enhancers, they are the positive regulators. So let me erase the things here. Exon splicing enhancers, they are nothing but the positive regulators of the alternative splicing mechanism. positive regulators. And whereas axon splicing silencers, they are the negative regulators. Negative regulators. Is it clear? So here the axon splicing enhancers, they are responsible for promoting the axon inclusion. So let me write it here. Axon inclusion. And whereas the negative regulators, they inhibit axon inclusion. Is it clear? And the other two factors which are a part of the alternative splicing mechanism include intron splicing enhancers. So here it is nothing but the positive regulator again. Positive regulator. And the other factor is nothing but what? Intron splicing silencers. And here it is nothing but what? The negative regulator. So here the positive regulator, again it is responsible for promoting the axon inclusion. Is it clear? And whereas the intron splicing silencers, they are responsible for preventing or for inhibiting the axon inclusion. Inhibits axon inclusion. Is it clear? So here this is regarding the alternative splicing mechanism which is successfully organized in case of higher eukaryotes. So here I hope that this video will help you a lot. So if you like this video, just hit the like button and share it to your friends. And I remember you people to subscribe my channel for getting more and more videos what I make day to day. Thank you.